Dear students, now I am going to discuss about crystal field stabilization energy. So, if you know the crystal field stabilization energy, the energy which required to fill the electrons in lower energy level orbital set in the geometries. That is T to G set in octahedral and E set in tetrahedral. Right, to stabilize the electrons in lower energy levels. So to calculate the crystal field stabilization energy in octahedral complexes, the formulae given as CFSC equals to minus 0.4x plus 0.6y delta O MP. If we see the terminology, where x is electrons in T2G set, where y is electrons in EG set, and where m is number of electron pairs, where p is pairing energy. If we take an example, hexa-aquo-cobalt 3 complex, where it is a weak field complex and cobalt is 27 atomic number and it has a electron configuration as argon 3d7 4s2, and it here the cobalt is in +3 oxidation state, therefore the electron configuration would be 3d6 system to T2G4 Eg2, right? So if we calculate the CFSC, minus 0.4 into electrons present in T2G set, that is X, 4 electrons, and 0.6 into electrons present in EG set, that is Y, that is 2 electrons, right? So if we calculate 0.4 delta O plus 1 pair in T2G4, 1 pair of electron is there, therefore 1p, 0.4 delta O 1p. If we take the another example, hexacyanocobaltate 3, that is strong field complex. So cobalt with the 27 atomic number, electron configuration 3d7 4s2, where cobalt is in +3 oxidation state with D6 system. So as the cyanide is the strong field ligand, so all the pairing of electrons will take place here. Therefore, the electron configuration is T2G6 Eg0. 3 electron pairs are here, right? So if we calculate the CFSC, minus 0.4 into X, that is electrons in T2G set, that is 6, plus 0.6 into Y, that is electrons in EG set, that is 0, delta O, plus number of electron pairs are 3 here, therefore 3p. Therefore, the CFSC is minus 2.4 delta O plus 3p. If you see the CFSC calculations in octahedral complexes with different electronic systems, once we are considering as weak field complex, once we are considering as strong field complexes, and writing electron configuration for weak field complex and calculation of CFSC, writing electron configuration for strong field complex and calculation of CFSC, right? If it is D1 system, the electron configuration will be T2G1 Eg0, where it is weak field complex. And strong field complex, of course, the electron configuration would be same, T2G1 Eg0, and CFSC will be same. For D2 also, T2G2 Eg0 and CFSC minus 0.8 delta O. And strong field complex, of course, the electron configuration is T2G2 Eg0 and the CFSC is minus 0.8 delta O. For D3, T2G3 Eg0 and the CFSC is minus 1.2 delta O. Of course, for strong field complex, T2G3 Eg0 and the CFSC is minus 1.2 delta O. And for D4, it is weak field complex, no? Therefore, all the orbitals will be singly filled up. That's why the electron configuration is T2G3 Eg1. and the calculated CFSC is minus 0.6 delta O. So it is strong field complex, right? So therefore, the orbital electron pairing will be takes place first. Therefore, T2G4 Eg 0, and the calculated CFSC is minus 1.6 delta O plus 1 pair plus 1. We see the D5 system for weak field complex. The electron configuration is T2G3 Eg2, and the CFSC value is 0. And for strong field complex, T2G5 Eg0, and the calculated CFSC is minus 2 delta O plus 2 electron pairs 2p. And for D6 system, the electron configuration is T2G4 Eg2, and the calculated CFSC is minus 0.4 delta O plus 1 electron pair. And for strong field complex, T2G6 is 0, and the calculated CFSC is minus 2.4 delta O plus 3p. For D7 system, for weak field complex, the electron configuration is T2G5 Eg2. The calculated CFSC minus 0.8 delta O plus 2 electron pairs. And for strong field complex, T2G6 Eg1 is the electron configuration, and the calculated CFSC is minus 1.8 delta O plus 3 pairs. For D8 electron system, the electron configuration for weak field complex is T2G6 Eg2, and the calculated CFSC is minus 1.2 delta O plus 3 electron pairs. And the electron configuration for strong field complex is T2G6 Eg2, and the calculated CFSC is same, minus 1.2 delta O plus 3p. For D9 system, the electron configuration would be for weak field complex T2G6 Eg3, and the calculated CFSC is minus 0.6 delta O plus 4 electron pairs. And for strong field complex also, the electron configuration is T2G6 Eg3, and the calculated CFSC is minus 0.6 delta O plus 4 electron pairs. And for D10 system, the electron configuration for weak field complex is T2G6 Eg4 is 0 plus 5 pairs, and for strong field complex also, the electron configuration is T2G6 Eg4. The CFSC is 5 pairs only.